Today we are doing lesson 3.6, transformations of graphs of linear functions. Now, as a quick review, a linear function has what kind of a graph? A line, okay? So the graphs that we are talking about today are lines. But the main focus of today are transformations. Now, last year you did 4 transformations, and some were similar to what we're going to do this year, and some are very, very different. But let's try to review and think back to last year. And keep in mind, last year when you did transformations, you were on an X and Y chart and you were actually doing things to the pictures and the shapes. All right, does anybody remember one of the transformations that you learned last year? Rotations. You took the shape and you moved it around the origin. That was a rotation. All right, what's another one? Close. It's got a different name, but sliding is technically what you're doing. You're sliding it up, down, right, or left.
Reflection?
A reflection is one. Okay, you took your shape and you reflected it either over the x-axis or the y-axis. Okay, so we've got rotations and reflections. What about when you made a shape bigger or smaller and they do it to your eyes at the eye doctor? Dilation. All right, dilation was one. And then the one that Tommy mentioned, the sliding, that's called a translation. You took the shape and you moved it up, down, right, or left. Now, we are only going to be looking at 3 transformations this year. 2 of them you've done. We're going to be doing translations and reflections. But the new one, the third and new one we're going to do are stretches and shrinks. Now, here's the other information for you. Last year, you were physically on an X and Y chart. You were on a graph, and you were moving shapes and redrawing shapes. Our focus this year when we talk about transformations is going to be less on graphs and more on equations. We're going to look at equations and be able to determine from an equation what transformations have been done. But don't let me get ahead of myself. Let's start with the essential question. How does the graph of a linear function f of x equal x compare to the graphs of g of x equals f of x plus c and h of x equals f of cx? Okay, so basically we're going to be looking at an original problem and we're going to be looking at a new problem and figuring out what transformations have been done. Now you're going to hear me say this over and over. A parent function. So grab your highlighter and highlight parent function. The parent function is going to be f of x equals something. F of x equals something. And listen, the parent function is essentially the original problem, the original function. And then we're going to be looking at a new function and deciding what transformations happened to those parent functions. And again, as a quick review, f of x could be replaced with which variable? Y. Okay, so our parent function is going to be f of x equals, it could be x, it could be f of x equals x plus 2, it could be f of x equals 1/2 x minus 6. Okay, but f of x is just essentially the original problem. Now, the transformations of these functions will change the size, the shape, the position, or the orientation of the graph. So each transformation will do something different, but it could change the size, the shape, the position, or the orientation. Now, I told you we've got 3, and we're going to highlight those 3. We're going to look at translations, reflections, and shrink or stretches. Now, I realize it says horizontal shrink stretch, vertical shrink stretch, but we are only going to highlight the 3 transformations right now. There's translations, reflections, and shrinks or stretches. Now let's talk about a translation. It shifts the graph horizontally or vertically, but it does not change the size, shape, or orientation of the graph. So a translation simply takes the line and moves it right, left, up, or down. It doesn't do anything else to the graph but move it right, left, up, or down. Now a reflection flips the graph over a line called the line of reflection. You know it better as the x-axis or the y-axis. So I want you to circle x-axis or y-axis. Your line will be reflected over the x-axis or the y-axis. And the stretches and the shrinks. Now this is probably the most difficult of the 3 transformations. But look at what it says. If it's a horizontal shrink or stretch, the graph shrinks toward the y-axis or stretches away from the y-axis, which is a little strange because what's the horizontal axis on a coordinate plane? Which axis is the horizontal axis? The x, okay? But in this horizontal stretch or shrink, it actually shrinks toward the y-axis or it stretches away from the y-axis. But look at the vertical. Same thing. What's the vertical axis?
Up and down.
Okay, but what's the vertical axis on a coordinate plane? The y-axis. But in a vertical shrink or stretch, the graph shrinks towards the x-axis or stretches away from the x-axis. Now, if you're a visual learner like me, that really is a little bit confusing. But again, we're going to be looking at equations more than we're going to be looking at graphs. Now, that brings us to our cheat sheet. So grab your cheat sheet. And remember, only put on the sheet what I tell you to. If I tell you not to put it, then don't put it. Just because I put it on the screen doesn't mean you are putting it on your sheet. For example, I'm going to circle where we're starting. We're going to focus first right here on our cheat sheet. The horizontal, now we are not calling it a shift, so the first thing you are going to do is you're going to cross out the word shift and we're going to change it to the word translation. Different curriculums use different words and our curriculum uses translations. So cross out the word shift and change it to the word translation. Now, I want you to then shift your focus to these little formulas right here in the middle. And this is the first thing, you don't need to circle it, but this is the first thing that we're going to do on the cheat sheet, and it's the first thing we're going to do when we go into working problems. We're going to take our highlighter today and we are going to highlight f of x, because remember, f of x is the parent function. If I go through and I highlight everywhere I see f of x, it should help me to more quickly see what they've done to the parent function. Now, they've done one or two things in these translations. Can you tell me what's the one or two things they've done to each of these parent functions? They added or subtracted. So, we're going to give ourselves, I am going to allow you to write down this hint in the box. Add or subtract a number. So if you can recognize in the new function that they have added or subtracted a number, then that should take you to the translation part of your cheat sheet. So add that little shortcut or that little hint in both boxes. If you add or subtract a number, it's going to be either a vertical shift, a vertical translation or a horizontal translation. Okay, so that's just an extra little piece of information that I allow you to put on there to try and help you. Now, once you've decided that they've added or subtracted a number, now you have to decide, did they add the number to or subtract the number to f of x or just x? So the next thing I'm going to have you add at the top of your cheat sheet, I want you to write f of x question mark or just x question mark. Because this is going to help me decide if it is horizontal or if it's vertical. I'm already going to know it's a translation because they added or subtracted a number. What I'm trying to figure out, is it a horizontal translation or is it a vertical? So I'm going to ask the question, did they add or subtract the number to f of x or just x? Now listen, here's the key to this. If they've done anything to just x this entire day, if they have done anything to just x, it will be in parentheses. So this should not be confusing. If the number is not in parentheses, then they have not done it to just x. So let's start with this right here, and you don't need to circle this, just look at it. They have added h. The question is, did they add it to f of x or just the x? So what do you think? Why just the x? Good. They're in parentheses with the x. So if they've done this, if they've added a number to just x, then it is a horizontal translation. Now, horizontal is not going to be our favorite today because look, if I'm on the horizontal graph, which is the x-axis, what direction is typically positive on the x-axis? To the right. But look, if they're adding a number to just x, they're actually moving what direction? To the left. Now, you are going to have the cheat sheet in front of you, but if you don't know how to interpret it, it's really not going to be that much of a help. So, circle the word left because you do not have it in red on your paper like it's in the screen. Now, look what happens if they are subtracting a number from just x. They're still in the parentheses, so they're still doing this to just the x, but they have subtracted a number. What direction is usually negative on the x-axis? The left. But look at what direction you're actually moving. To the right. So be very careful. If you identify it as a horizontal translation, be very, very careful when you're choosing your direction. Now, look at this one. Plus k. Are they adding k to f of x or just x?
Just a.
To f of x, right? They're not in the parentheses this time. They're outside the parentheses. So this time they're adding a number to f of x, which makes this a vertical translation. Now, we like vertical because the vertical axis is y, and what direction is positive on the vertical axis? Up. And look at this. If I'm adding k to f of x, I'm moving the graph up. So circle the word up. On the flip side of that, if I'm subtracting a number from f of x, what direction is negative on the y-axis? Down. In what direction am I moving? Down. So we like vertical because it's more what you see is what you get. Now, this is all you can have on your cheat sheet. So if you've added any circles or any arrows, erase them. This is the only thing that I will allow you to have on your cheat sheet. Now, keep it right there because we're going to work some problems. Example number 1 says use the graphs of f and g to describe the transformation from the graph of f to the graph of g. Now, first things first, highlight f of x is the parent function. Because once again, I need you to understand f of x is the original problem. That's not where we're looking for the transformation. So here's what you're going to see me do. I'm going to go to the problem and I'm actually going to cross out the parent function so I don't get confused. I am not looking at f of x equals negative 2x right now. I'm going to the new function, which is right up here, and is g of x equals f of x plus 2. Now, just like we did on the cheat sheet, we're going to highlight in our notes, okay, we're going to highlight the f of x, the parent function. Because notice, they don't put the negative 2x, they just use f of x. So I want you to take your highlighter and I want you to highlight f of x, just like we did on the cheat sheet. Because if I can find and identify the parent function, I should be able to see very quickly what was done to the function and what was being done to this new function. Added a number. So if they are adding a number to the parent function, what transformation? And please don't say vertical or horizontal. Those are not transformations. Those are directions, but those are not transformations. If they are adding a number, what type of transformation is it? A translation. So go to the translation part of your cheat sheet. The next question. Are they adding to f of x or just x? To f of x. So is it vertical or horizontal? It's vertical. So underneath the graph, we're going to write vertical translation. We already knew it was a translation, but we didn't write anything down until we knew if it was vertical or horizontal. Now, the direction. They're adding a 2. So if you're adding a number to f of x, what direction is that according to your cheat sheet? Look at your cheat sheet. Go to where it says vertical translation, and we are adding a number. So what direction is that? Up. Vertical translation up. How many units? 2. Whatever the number in the problem is the number of our units. So vertical translation up 2 units is the transformation that was done to this graph. Let's move to letter B. What's the parent function this time? F of x equals 2x minus 1. So again, I'm going to cross it out because I don't want to get confused. That's my original problem. My focus has to be on the g of x, the new function. What did they do to the parent function? So again, highlight f of x. That's the first thing we're trying to find and highlight. When you do that, Andrew, you can see pretty quick that they've done what to the parent function? They're adding a number, which makes this what kind of transformation? Not vertical. Again, vertical and horizontal are not transformations. I'm trying to get you, because eventually we're going to have all these transformations. You need to know which transformation you should be focused on. So if they are adding a number to the parent function, what transformation are you looking at on the cheat sheet? A translation. All right, so you should be on the translation part of your cheat sheet. Now, Andrew, have they added 3 to f of x or just the x? F of x, which makes this vertical or horizontal? Vertical. So now we can write down that it's a vertical translation. But what direction? They're adding a number to f of x. So what direction is that? Up. How many units? 3 units. So there is your transformation. A vertical translation up 3 units. And that's what you're going to box in. All right, work letter C on your own. First things first, I'm going to mark what out? The parent function, the f of x equals 2x minus 1, because again, that's not where my transformation is going to be found. All right, in the new function, what's the first thing we're finding and highlighting? F of x, okay. So Tyler, when you highlight f of x, what can you see pretty quick they've done to f of x?
You put x in parentheses.
Okay, but that's not where my focus is. We're looking at the things not highlighted. So what is not highlighted?
Plus 3 g of
Okay,
x.
so what have they done to the parent function? Don't make it too complicated. We've got the parent function, f of x. What are they doing to f of x? They're adding a number. So what transformation should we be going to on our cheat sheet if they're adding a number?
Well, after adding a number, should be horizontal, right?
But horizontal is not a transformation. That's a direction. What's the actual transformation?
Translation.
It's a translation, okay? Not even horizontal yet. We're not there yet. We're just trying to figure out where on our cheat sheet we should be. So if they are adding a number to the parent function, we go to translations at the top of our cheat sheet, okay? Now, Tyler, are they adding 3 to f of x or just x? Just the x. Again, how do we know? Because the plus 3 is in parentheses. So is that horizontal or vertical? That's horizontal. That's how we know it's horizontal. But we got to be careful. As soon as we write down horizontal translation, we probably want to slow down and make sure we don't get ahead of ourselves. They're adding a 3, which essentially means they're moving it what direction on the x-axis? To the left, okay? Naturally, we would think right, but it's the opposite. So it's a horizontal translation left. How many units? 3 units. Back to your cheat sheet. Okay, you are not going to circle this, but I'm going to show you where we're focused right here on reflection. Now, reflection is a little bit simpler. Okay, if you go to this middle section right here, let's highlight once again, find and highlight the f of x. Just the f of x. Because if I highlight f of x, which again is the parent function, the original problem, what do you notice they've done to f of x this time? Okay, I heard it. There's now a negative sign there, okay? Somebody said multiply. The problem with that multiply is there's no number, all right? So this is a simple sign change. So the little hint that you're going to give yourself underneath reflection is sign change. A reflection will never include a number. So if there were a number in your problem, a negative sign and a number, then you've got 2 transformations happening in that one problem. A sign change is the reflection. A reflection will never include a number. Now look at this. We're still asking that same question at the top. Once we realize it's a sign change, the question is, did they change the sign of f of x or just x? Right here. Did they change the sign of, let me finish. Did they change the sign of f of x or just x? F of x. Okay, again, they'd be in the parentheses with x if it was just x. So that is a reflection across the x-axis. So I want you to circle x-axis. Now, let's think about that for a second. F of x, I could replace f of x with a what? With what letter? With a y. So essentially what we're saying is they've changed the sign of y, but look at what it reflects across. The other axis. So again, it's kind of the opposite of what you would think. But if they change the sign of f of x, it's a reflection across the x-axis. Now, what did they do in this one? Did they change the sign of f of x or just x?
Just x.
Just x. They're in parentheses with the x. So this is a reflection across the y-axis. Now, circle. Make sure this is all you have on your cheat sheet. Okay? And then let's look at example number 2. Use the graphs of f and h to describe the transformation from the graph of f to the graph of h. So once again, highlight where it says f of x is the parent function. I'm going to drill that into you today. So looking at letter A, that means the parent function we don't want to focus on. We're crossing it out. We're going to the new function to see what they've done. So just like we've been doing, we're going to find and highlight f of x. If we can find the parent function, we should be able to see quickly what they've done to it. So what do you notice when you highlight f of x? What do you notice has been done to this problem? Now we're up to 3 options. They've either added a number and subtracted a number or changed the sign. So what have they done? They changed the sign, which takes me to which transformation on my cheat sheet? A reflection. So we can go ahead and write down reflection because we know it's a reflection and we know it's a reflection across something. So reflection across. Now the question, did they change the sign of f of x or just x? Just x. They're in the parentheses. So that's a reflection across which axis? The y-axis. Wonderful. Box it in. All right, letter B. Cross out that parent function because we don't want to get confused, but go find the parent function in the new function. So h of x equals f of negative x. When you find that parent function, what do you notice they've done? Change the sign, which is what transformation on your cheat sheet? Reflection. So again, we can go ahead and write reflection across. Did they change the sign of f of x or just x? Which makes this a reflection across the y-axis. Again, why is it just x? Because they are in parentheses with the x. All right, do letter C on your own. All right, we cross out the parent function. Find the parent function in the new function, and what do you see right away they've done? Have they added something, subtracted something, or changed the sign? They've changed the sign, which takes me to what transformation? It's a reflection across. Have they changed the sign of f of x or just x? F of x this time. So this is a reflection across the x-axis. So reflections are a little bit easier as long as, let me reiterate, a reflection will not include a number. The reflections are the sign changes only. Now, back to our cheat sheet. This is the most difficult of all the transformations. The stretches and the shrink. So we're right here. We're down here at the bottom. First things first, cross out everywhere you see the word compress and put shrink. Everywhere you see the word compress, we're going to cross it out and we're going to put shrink. Again, some curriculums use the word compress. Ours uses the word shrink. So cross those out. And please do it, because if you use the word compress on a quiz or a test or a homework, you will lose points. Now, again, vertical and horizontal are not translations. The translation is a stretch or a shrink. Take your highlighter, and here in the center, we're going to highlight f of x again. F of x, f of x. Be very careful. You don't want to get anything but f of x in your highlighted portion. Now, for this first part, let's just focus on these 2 boxes right here. Okay? What are they doing to f of x in those 2 boxes? Multiplying. You have an a and an f with nothing between them. Okay? You don't need an arrow right there. You got an a and an f with nothing between them. That's multiplication. So, the hint for these transformations are multiply by a number. So if you can decide that they have multiplied by a number, you should go to your stretch or your shrink on your cheat sheet. So multiply by a number. Now this is where it gets tricky. Okay, and again, we're still right here. Have they multiplied by f of x or just x in these 2 boxes right here? F of x. So first thing we know is this is a vertical stretch or shrink. Here's what we have to do though. We have to take that number and we have to plug it into these 2 inequalities. So I want you to circle these 2 inequalities. If your a value, the number they're multiplying by, is greater than 1, you have a stretch. Now look, it's a stretch by a factor of a. So I want you to circle the a too. Again, vertical, we like. Vertical, it is what you see. So if a is greater than 1, then it's a vertical stretch by a factor of whatever that number is. Then you've got an a value that falls between 0 and 1. What kind of numbers fall between 0 and 1? What kind of numbers? What type of numbers? Fractions fall between 0 and 1 because we're not usually going to be using decimals. Fractions fall between 0 and 1. So if your a value falls between 0 and 1, you have a shrink, a vertical shrink, again, by a factor of whatever that number is. Now you got to be careful with fractions because if I give you an improper fraction like 3 over 2, what does 3 over 2 actually equal? 1.5. And 1.5 is actually greater than 1. So don't automatically, you just got to be really careful. But if it's a fraction like 1/2 or 1/3 or 2/5, then it is a vertical shrink by whatever that number is. Okay? Again, though, horizontal gets trickier. So if you go over here to your vertical, again, you can see that the number is being multiplied by just the x because it's in parentheses. Okay? Same thing though, you've got to take that a value and you've got to plug it into one of those two inequalities. So circle those inequalities again. Now look what happens if it's horizontal. If a is greater than 1, you actually have a horizontal shrink. And look at this, it's now by a factor of 1 divided by a. So you're no longer just going to be able to use the number in the problem, you're going to have to actually put that number underneath a 1, and it's going to create a fraction. Okay? Look what happens if it falls between 0 and 1. If it's a fraction and it falls between 0 and 1, you have a horizontal stretch. Again, look at this, by a factor of 1 divided by a. So you're going to have to take the number 1 and divide it by a fraction. All right, so you got to be very careful when it's a horizontal stretch or a horizontal shrink. And we're going to look at these in example number 3. But first, make sure this is all you have on your cheat sheet. Okay, no extra circles, no extra arrows, no extra words. Now, let's look at example 3. It says, use the graphs of f and r to describe the transformation from the graph of f to the graph of r. Again, highlight the fact that f of x is the parent function. So looking at letter A, let's cross out that parent function so we don't get confused. And this is our new function. Again, that is r of x equals 2 times f of x. So first things first, what are we finding and highlighting? F of x, the parent function. I understand in your homework, quizzes, and tests, you might be circling because you don't have a highlighter. But for now, we have our highlighter. So highlight f of x. And what can you see very quickly that they're doing to that parent function? What are they doing with that 2? They're multiplying. So which transformation should we be on our cheat sheet? Stretches or shrinks, okay? So go down to that part of your cheat sheet, take the 2, and ask yourself, are they multiplying f of x by 2 or just x? F of x. So what's, is that vertical or is that horizontal? That's vertical. So go ahead and write down vertical. Now, we don't know yet if it's a stretch or a shrink because we have to take the 2 and plug it into those inequalities. Which inequality does it fit into or make true? A is 2 though. Is your 2 greater than 1 or does your 2 fall between 0 and 1? Those are your options. So what's the case with the 2? Which one does it fit into? Is 2 greater than 1 or does 2 fall between 0 and 1? That's the question. It's greater than 1. So if it's greater than 1, it is a vertical stretch or a vertical shrink? Stretch. According to my cheat sheet, when it's vertical, if A is larger than 1, it's a stretch. And this one is because it's 2. And this is a vertical stretch by a factor of what? 2. Remember, with verticals, we just get to put in the number from the problem. So a vertical stretch by a factor of 2. Now, letter B, let's cross out the parent function. Go into the new function and highlight f of x. Remember, we're finding and highlighting the parent function. So what do you notice when you find your f and your x? What's happening in this problem? Okay, what are they doing with the 1/2? They're multiplying. So which transformation should you be on your cheat sheet?
What's it called?
Stretches or shrinks? Stretches or shrinks. Now, are they multiplying 1/2 by f of x or just x? So is that vertical or horizontal? That is horizontal, so we got to be really, really careful on this one. Horizontal. Take your 1/2 and plug it into those inequalities. Where does it fit? Is your a greater than 1, or does your a fall between 0 and 1?
0.
Between 0 and 1, because it's a half. So is that a stretch or is that a shrink?
Shrink.
Look at your cheat sheet. Remember, horizontal is never what you think it's going to be. Okay? It falls between 0 and 1. So on your cheat sheet, that is a horizontal what? It's not a shrink.
Stretch.
It's a stretch. Look at the little formula. If a falls between 0 and 1, it's a horizontal stretch.
Oh, yeah.
Now, it's also by a factor of what?
1/2.
No. Go look at what we circled. If it's horizontal by a factor of, you have to actually do a little bit of math. So over here on the side, and this is not optional, I need everybody to write this down or you'll never remember what we did. Okay? It's by a factor of 1 divided by a. So for this problem, it's 1 divided by what? What was our a value? No, not in our problem. What was the a value? 1/2. So we have to do 1 divided by 1/2. Now, we're going to rewrite this so it looks like a division problem. It's 1 divided by 1/2. Have you ever been able to divide fractions? No. Okay, so right above this little problem, I want you to write KFC. Keep, flip, change. You have to keep the first number, flip the second number, and change it to what kind of a problem? Multiplication. So what is 1 times 2? 2. So what's the actual factor in our answer? 2. So see, you've got to be so careful when it's a horizontal stretch or a horizontal shrink. Horizontal just changes everything. Now, letter C, let's cross out the parent function, highlight the parent function in the new function, and what do you see they're doing? Multiplying. So that takes me to what transformation on my cheat sheet? Stretch or shrink. And are they multiplying by f of x or just x? Which makes this vertical. And which number or which inequality does 4 fit into? Okay, but that's not an inequality. What inequality? Is 4 greater than 1 or does 4... Hold on, let me finish the question. Is 4 greater than 1 or does 4 fit between 0 and 1? It's greater than 1, which makes it a vertical stretch. And again, it's vertical. So a vertical stretch by a factor of what? By a factor of 4. And that is lesson 3.6.